Let's try simplifying some square roots. Remember that when we're talking about square roots, if a squared is equal to b, then a is going to be the square root of b. So what we mean by that is, since 5 squared is 25, that's going to mean that the square root of 25 is 5. Of course, it doesn't always work out so nice. For instance, when we had the square root of 20, the square root of 20 isn't a perfect square root. So we typed it into our calculator and came up with a decimal approximation. We said that it was about equal to 4.47. Now, how do we simplify a square root expression that keeps it as an exact value, but does simplify the expression some? Well, there are actually a couple rules to simplifying radical expressions. The first one is that the radicand, that number that's underneath the square root, can't have any perfect square factors. We want to take the square roots of those perfect squares out of the number. The second rule is that the radicand, the number under the square root, is not a fraction. And the last rule is that if we have a fraction, it can't have a radical or a square root in the denominator. Right now, we're not going to go through all these and see every variation of the different types of radical expressions that have to be simplified, but we will look at a couple in particular. First, we're going to start with this second rule, where the radicand is not a fraction. This is what I mean by that. The square root of 9/25. That number that's under the square root, 9/25, is a fraction. In order to simplify this, all we have to do is break up the square root into the square root of 9 over the square root of 25. Now, we know how to find each of those square roots. Since 3 squared is 9, the square root of 9 is going to be 3. And we already saw that the square root of 25 is 5. So, this expression simplifies to 3/5. Let's try another one, the square root of 49 over 16. Well, first we break this up into the square root of 49 over the square root of 16. Then simplify each square root. The square root of 49 is 7, and the square root of 16 is 4. So this fraction simplifies to 7/4. But here's one where the radicand isn't even a fraction. The square root of 25 times 3. So the radicand is actually a product. It's a multiplication of 25 and 3. And the thing about 25 is that that is a perfect square, however 3 isn't. Now we can break up this square root in the same way we did the fraction, as the square root of 25 times the square root of 3. Then the square root of 25 is 5, but the square root of 3 can't be simplified. 3 is a prime number, its only factors are 1 and 3, so this is as simple as it gets, and we would write it as 5 square root of 3 without putting that multiplication symbol in between. Sometimes you have to find that perfect square factor on your own. What I mean by that is a number like the square root of 20. We already know a lot about 20, that 20 is 2 times 10, but 2 and 10, they're not perfect squares. We also know that 20 is 4 times 5. And we'd much rather look at 20 as 4 times 5 because that 4 is a perfect square. Now we can break this up into the square root of 4 times the square root of 5, with the square root of 4 being 2, and the square root of 5 being a number that we can't simplify. So this is our simplified expression. But let's say we have a larger number that you don't really feel comfortable about, like the square root of 63. How are we going to try and simplify that, searching for those perfect square factors? Well, what you should do is think about your perfect square roots, starting with about half of that radicand. So take 63, divide it by 2, and we get about 30. So we're going to think of our list of perfect square factors. 36 is a perfect square, but that's bigger than 30. We don't want to start with 36. We'll start with the next one, 25. So take 63, divide it by 25, and you get 2.52. Because this is a decimal number, it's not going to work out for us. So we should start working down the list. The next perfect square lower than 25 is going to be 16. So we take 63 divided by 16, and we get 3.9375. Also a decimal number, also not going to work. So we work our way down. 16 was 4 squared. The next one smaller would be 3 squared, 9. And 63 divided by 9 is 7. Once we get that to be a nice round number, we know that we've got good factors. So 63 we can rewrite as 9 times 7. Now we split it up into our square root of 9 times the square root of 7, square root of 9 being 3, square root of 7, we can't simplify, and we're done. Let's try that one more time. With 112, half of 112 is 56. 56 isn't a perfect square, so we go to the next one smaller than that, which would be 49. And try 112 divided by 49. And we get 2.285. Decimal number, not going to work. So work your way down from 49. 49 was 7 squared. 6 squared is 36. 112 divided by 36, 3.111. Another decimal number. So 6 squared doesn't work. Try 5 squared, 25. 112 divided by 25 is 4.48. Still doesn't work. Keep working your way down from 5 squared to 4 squared. 112 divided by 16 is 7. Once we get that 7 right there to be a number that has no decimals after it, then we know we can factor 112 into 16 times 7. Now split up that product into square root of 16, square root of 7. Square root of 16 is 4. Square root of 7 is the square root of 7. Now we have our simplified expression.